completed all 5 steps on how to do standard deviation. So now we're going to be talking a little about how to read standard deviation and also like what did we just do? So let's get into a note. So first thing I'm going to point out, we still have the video. This is the video introducing calculating standard deviation. You may have noticed in the video that there are some symbols that we aren't really using in class, mostly because it is very, very impossible to make sure that everyone can do it. So I just did want to bring attention to that. I also want to bring attention to yesterday's work. There was a small error in the example. Some of you early birds got everything done a little before I was able to correct it. So I will be bringing attention to that today during this as well. So let's get into it. Congratulations, you did it. You successfully completed all the steps to calculate a standard deviation of a data set. Yay, you. Now, what does that mean exactly? So let's look at our notes. Our notes are steps to calculate standard deviation. 1, calculate the mean. 2, subtract the mean from each data point. Remembering you could have negatives, and that was cool. 3, square each difference, which is actually the action that got rid of the negatives in step 2. 4, calculate the mean of the square differences. So you are just finding mean again, which just means add all the numbers, divide by the number of data you had. And 5, the least, take the square root, which we all did through our calculators, and hopefully you did use a decimals. So looking at the scenario, so the scenario was you surveyed your friends, asked them how many vegetables did they have at home, and you got answers from 5 different people, 2, 3, 4, 7, and 9 vegetables. So you had 5 numbers in that data set, which is why you were dividing by 5 in the means. So that would be step 1 and step 4. Through our meticulous and accurate calculations, we found the mean of the data set of the 5 numbers was 5. So we're talking about the original data set, not the data set of the differences, the differences, the mean of the differences. We're talking about the original data set. So that is 5. So let's keep an eye on that 5. I'm just going to bold it. And then we found the standard deviation was plus or minus 2.6. Now the plus or minus is really significant in a moment. This means the majority of the data is located, so from the mean minus 2.6 and from the mean plus 2.6. So if the mean is the center, and I'm going to bring it down here because this is the graph that actually matches this data. The mean is about the center, so that was 5. And the data was 5 minus 2.6, so between 2.4 and then 5 plus 2.6, 7.6. So looking at the graph, we have the 5 minus 2.6, which we know is 2.4 because I did the calculations, and the 5 plus 2.6, which we know is 7.6. Again, I did the calculations, which means that the most of our data fell between this section. Now this graph should look extremely familiar, and I gave you the little hint. Does it ring any bells? That's right, this is in fact a bell curve. So we're talking about normal distribution of a bell curve, and then it has really predictable data. So that's why we can use standard deviation to kind of determine where the data falls. Now you might hear first standard deviation and standard deviation. Sometimes it is in percentage, which I do ask you to read in the class notes. But this is the entire point of standard deviation. We want to know what is that area, the plus and minus from the mean that our data falls into. So in conclusion, the majority of the data for this scenario is between 2.4 and 7.6. Remembering that I got 2.4 because I took the 5 minus my standard deviation, which was 2.6, and I took the 5 and I added my standard deviation, 2.6, to get 7.6. So my data is between 2.4 and 7.6. That is the point. So I did mention earlier in the beginning of this video, I did make a mistake that some of you early birds got past me, and it was actually in the standard deviation from yesterday. So this scenario in my notes and discussion is actually from yesterday. So some of you might have seen that I actually took the square root of the calculate the mean. How did I do it? I don't really remember, but somehow it ended up being 5.6 or something like that, and it was clearly wrong. So you may have received a note. Mr. Barrett, I know, is doing the grading right now. You may have received a note saying that it was a little off. that is why I got carried away, and I think I did the square root of 35, which was silly because I had to do the square root of 6.8, which is how I got 2.6. I did correct it. If you look at scenario 1 down here, I did in fact correct it. Yeah, I did the square root of 34. I was just so excited to square root. I square rooted the first number I saw. Unfortunately, it was the wrong number and should have been 6.8. So that correction is down here. So let's look at what the assignment is today. So looking at part 1, directions, I want you to identify what is the standard deviation. This one we just discussed. This one is going to be a little more challenging. I want you to look at it very carefully. We've actually seen this one before when we talked about normal distribution, and the answer is hidden there. This one is a little more complicated. It does, however, have the information. I'm actually going to make it a little bit bigger while I'm in this slide so you can see it. It's going to be this symbol. So the 1s, X bar means mean. 1s is 1 standard deviation. So you're going to be reading this right here. I also ask you about the percentage of the data. So you're going to be reading this right here. And that's actually a really common way we read standard deviation. Just to give you insight, statistics are your friend, and most college-bound students will have to take a mandatory statistics class. I had to take like 6,000. So looking at scenario 1, it's going to ask you, so this is part 2, you're just going to be writing the conclusion. So scenario 1 is the example, so you're going to have a great time doing that, as well as scenario 2. So I'm going to be asking that you do the plus minus and tell us the region it would fall into, as well as scenario 3. I would keep the decimal place as the standard deviation is. So this is in hundreds. I would keep it in hundreds. This is in tenths. Keep it in tenths. This is in tenths also. Get it? It's in tenths. This is also in tenths, so just keep it in tenths. You guys are going to do great. You're already doing great in this. I really congratulate you on the hard work that you're putting into your math. I know this is not an easy way to learn. Enjoy. I look forward to grading it. And if you have any questions, please never hesitate to email us.